Okay, finally, let's talk about the 4.0 questions in this unit. The first one says to convert the following function from standard form to vertex form. So to do this, we're going to do a form of completing the square. Only we don't have another side of the equal sign to work with, so we're just going to have to keep everything on one side of the equal sign, but basically the steps are still the same. So we still want a perfect square trinomial, so we're going to half it, square it, add it to that 8. And this time, half of 8 is 4, squared is 16. So we're going to add 16 to that 8. And I'm going to put that in parentheses to kind of keep that separate. We still have this plus 13 out here. Now, since we can't add 16 to the other side of the equation, but we don't want to change the equation, we're going to go ahead and subtract 16 right here, just so that everything stays equal. Then I'm going to factor this as x minus 4 squared. So I just factored that perfect square trinomial. I'm going to go ahead and simplify this, and we're done. That's how you convert a function from standard form to vertex form. If you remember, vertex form just tells you what the vertex of the quadratic is. So this vertex would be 4 comma negative 3, which if we use the vertex formula and we look at standard form, opposite of b over 2 times a would be 8 over 2. So our value for our x would be 4, and then if we plug that in, we would still get the negative 3. So that's it for converting from standard form to vertex form. I'll show you one more. It's not on the review, but that way you have another one. So let's say we had f of x equals x squared plus 6x plus 7. So we are going to keep the part that we want to factor separate, and we're going to put that plus 7 on the outside. We're going to half it, square it, add it. Half of 6 is 3, squared is 9. And since we added it, we're going to have to subtract it over here. And then we're going to factor that as x plus 3 squared, and then add up the 7 and negative 9. And so there we went from standard form to vertex form. So pretty easy. Let's look at your next questions on the review. So on this one, you are just simplifying these square root expressions. We've actually done this before in class. You're just going to FOIL this out. 7 times 3 is 21. 7 times root 5 is 7 root 5. Negative root 2 times 3 is negative 3 root 2. And negative root 2 times root 5 is negative root 10. And we're actually done with that question because, as you can see, none of these are like radicals, so we can't combine any of them. And we also can't simplify any of the radicals because none of those radicands are divisible by a perfect square. So that's it on that question. On B, we see a radical in our denominator, which we aren't allowed to have. So we are going to rationalize the denominator, and we're going to multiply by the conjugate, 3 minus root 11. So we just changed that sign in the middle. We have to do that on top and bottom. On top, multiplying by 1 doesn't do anything, so it's just 3 minus root 11. And if you remember, when we multiply by the conjugate, we can just do 3 times 3 and root 11 times negative root 11 because the other two things are going to cancel out. So root 11 times negative root 11 is negative 11. So I'm going to simplify this. And I don't like negatives in my denominator, so I'm just going to switch all the signs. And we're done. Same thing on C. We want to undo that radical in the denominator, so we're going to multiply by the conjugate. We're going to have to multiply across the top, so 2 times 5 is 10. 2 times negative root 7 is negative 2 root 7. Root 3 times 5 is 5 root 3. And root 3 times negative root 7 is negative root 21. Almost ran out of room there. Multiply across the bottom, we just do that. 5 times 5, we get 25. And root 7 times negative root 7 gives us negative 7. Can't do much on top to simplify, so we're just going to rewrite it as we see it. None of them can be simplified, and we can't combine any of them. And so that would be our answer. We look at all of our outside numbers, 10, 2, 5, 1, and 18. And they're not divisible by anything that will allow us to simplify. So that's it. And then on bottom, we're going to multiply by 1. On the bottom question, we are not allowed to have an I in our denominator. So we are going to multiply by the conjugate of it, 1 minus 3i on top and bottom. Multiply across the top, we get 7 minus 21i. Multiply across the bottom, we get 1. We do 1 times 1, and then 3i times negative 3i, which gives us negative 9i squared. Change the sign. And so we have 7 over 10 minus 21 over 10i. And neither one of those can be simplified, so that's it. That's our answer.